In this video, I am going to explain you various type of scales. How do we draw various type of scales in the in engineering? What do you understand by the scales, and how do we draw these scales? In this chapter, in this assignment, this is assignment number 2, and you will find 4 types of scales in this assignment, like what is plane scale. These two are diagonal scale, vernier scale, and isometric scale. 1, 2, 3 and 4. 4 types of scales are described here. So I am starting with the, actually, like this is your Indian map. This is your Indian map. Have you seen this sort of Indian map? Is there political map? You will see that there that the scale used is given in this map, and what they have written is that 1 mm is equivalent to 200 kilometer. 1 mm of this page of this scale is equivalent to 200 kilometer of the actual figure. So for drawing big drawings, we have to use certain factor which is called as RF. You have to multiply this RF, this 200 kilometer multiply with RF, then we can generate the dimension of the actual scale. So some factor is there which is called as reducing factor or reduction factor, representation factor. It has a lot of names. So we can reduce the length or we can increase the length. Like in case of watches, the gears are too small. The gears which you cannot even get it over on your finger. The gears are too small. So in order to make their drawings, we have to multiply this. RF should be greater than 1. So actual drawing is bigger than the real object. You should be able to understand. So in order to draw the scales, we are drawing the scale like we had a scale. In this scale we can draw mm's, centimeters, inches. So what we are drawing is also a scale, and we will represent what we are representing. Like we are drawing kilometers, we are drawing hundreds of kilometers, thousands of kilometers on just a simple line. So that is the representation of the big quantity. Okay, so what we have to see now in question number 1, it is a plane scale question. Okay, question number 1, it is a plane scale. So plane scale, so we had some quantities given over this scale. So first thing is the scale ratio. What is RF? A scale of 1:4, centimeters long enough measure up to 6 decimeters, show 35 centimeters. First of all, it is given as RF is given to you 1/4, and one length is given also, maximum length to which we have to draw the scale, what is the maximum length. So here it is given that we have to draw up to 6 decimeters. So 1 meter has 10 decimeters. So 6 decimeter means 0.6 meter. It is 0.6 meter long, and After getting this maximum length 0.6 meter in RF, you need to calculate LOS. It is length of the scale. Length of scale. You have to draw length of the scale. So what is the length of the scale? It is RF into maximum length. Maximum length of the scale given. So 1/4 into 0.6 meter. So it is going to be, you need to multiply with 100 to convert this into centimeters. So 4, this 25, this is 10. Now this is 5, 2, 5, 5 and 2, 3. So this is coming out to be 15 centimeters. Check it again. 5, 2, 5, 25, 5, 2 and 3. So this is coming out to be 15 centimeter. So here you should do, first you make a straight line which is of 15 centimeter. Line of 15 centimeter. Okay. Then this line represents, what did it represent? It represent 0.6 meters. This line represent 0.6 meter because we have multiplied it with the RF, so we have reduced it. So its actual length is 0.6 meter. So we can write it as 15 centimeters. Now we have to make 6 divisions of this line. So how do we do that? Make any angle with the drafter. Make any angle with this line like this, and take your compass. Mark 6 equal division with this compass. Mark 6 equal division with this compass. Any dimension. Take this point as this. 1, 2, 3, 4, 5 and 6. Mark any 6 divisions over there. Then you should join this. You should join this last division with this point, with this last point. Okay. Make it tight. Okay, then again you fix your scale to this position and make parallel lines up to this line. This is parallel to the baseline. Again this is parallel to the baseline. Again this is parallel to the baseline. Again this is parallel to the baseline. All these lines are parallel lines. Okay. So now you should make a small box, 5 mm box over there. Make a 5 mm distance and close this box. So in this scale only this box should be darkened. Rest of the scale is kept as light. So you have to take in consideration that everything, only the box is dark and rest of the things were just for your help. including any dimension, you will see exact divisions will be generated. If you had done correctly, exact divisions will be made, exact 6 division will be generated. So you have to mark here 0, 1, 1, 2, 3, 4 and 5. So this 6 segments represent 0.1 meter, as this is representing 0.6 meter. So every section represent 0.1 meter, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6 meter. So what we need to calculate, what we need to show here is, you can convert 0.6 meter into centimeter. 0.6 into 100 means it is 60 centimeters long. This is 60 centimeter. So what is this length? This is 10 centimeter. This is 10 centimeter. So what we have to draw here is 35 centimeter. 35. So every single block is of 10 centimeters. 60 centimeter, 10 centimeter. So 60, you have to make another division. Take your scale over here on the bottom point and make an angle, any angle with this drafter from this point. Okay, then you have to take the compass again, make small divisions, 10 small divisions, 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 9. Division over here, 9. You have to make it 10 division. Keep the distance between the arcs are same. Any distance arc, any angle you can take. So now you have to join the last point with this last arc. This is first line. You have to make your drafter tied on this plane, and then you need to draw the next one, which is exactly parallel with the first one. Then the third one must be parallel with the coinciding line. Okay, now you make these 10 divisions in this part. This is your first, this is second, third, fourth, fifth, sixth, seventh, 8th, 9th and 10th. So this is how we have drawn a 10 division of this part and 6 division of this part. This is called as plane scale. Now we have to draw 35 centimeter. So in order to draw 35 centimeter, this is the 10 centimeter, 20 centimeter, 30 centimeter, and from this 1, 2, 3, 4 and 5. So you take 5 divisions over here. Okay, and 3 divisions over here, and you join this with a light. Everything should be light, only the box is dark. So you can write over here 35 cms, centimeters cms. So this completes your scale 1, and you can write over here, because this representing centimeters, so you can write centimeters over here. So this is your complete scale. You can write over here plane scale. This is the way you have to draw the complete scale, and you must have to draw arrows also. This is your question number 1. देखिए आप, now I will explain you the second question. The second question is basically a diagonal scale, which is called as a diagonal scale. So in diagonal scale the things were same, like ROF and the maximum distance is the same, but its resolution means in a general scale we had a minimum resolution of 1 mm. We can't measure 0.1 mm over this scale. So basically in diagonal scale we can go for 2 digits after decimal for the calculation. So their resolution is one more step ahead of the plane scale, So how do we draw this diagonal scale? I am explaining you. So first of all, I had told you that RF and length of the scale, the method of calculating length of the scale is same. RF is given to you, I am doing second question. RF is given to you 4 by 200, and maximum length is given to you as 6 meters. So LOS would be equal to 4 by 200 into 6 into 100 centimeter. It will directly, I have converted into centimeters, so 100, 100, 2 and 3. So this is coming out to be 12 centimeters. So you just need to draw stepwise. See what I am going to draw. Just need to draw first a 12 centimeter line like this. This is a 12 centimeter straight line. Okay, but this will represent you a length of 6 meter. This is representing 6 meters. So we have to make a division of 6 division of this length. So you just need to have a compass, take any distance and at any angle. 1, 2, 3, 4, 5 and 6. This is for, because this is 6 meter representing 12 centimeter. 12 centimeter is equivalent to 6 meters. So we have made 6 divisions of this line. Okay, this is your first division, and make it tight. We have joined the last 2 points of the division. So then we make parallel lines from this point, like this, like this, like this, and like this, and like this. Then we have to make a 5 mm box, 5 mm box, like this up to this point. So this is the box which we need to make it darken. Everything rest of the scale is light, only the box should be visible as dark, rest of the things should be light. Okay, then we have to make the division on this end as earlier. Make any line, make a 10 division of this line, at any distance, any relevant distance, 1 2 3 4 1 2 3 4 5 6. I think this would become, this would not cover 10 points, so I will take another line and slightly slower slope so that we can cover 10 points over here. So you can take your compass and same distance I had taken, 1 2 3 4 5 1 2 3 4 5 6 7 8 9. It's again coming out to be very large, so we should reduce our distance. We can reduce our distance, and I will take a new line. This is pen, so I cannot erase it because I'm using pen over here. When 1 2 3 4 5 6 7 8 9 10. So I had taken smaller divisions and then I had joined the last point with this point. We have taken this middle line for the division, so you have to keep in mind. Okay, so now we have to draw the parallel lines, like this is second, this is for third, fourth. Every division should be very clearly made, and so now I had made the divisions in the first box, you can say. Okay, so at most I had tried to make a similar separation between these divisions, but if you do it more carefully, then you may find exact separations between these. Should be exact separation between them. Now for the diagonal scale, you have to write over here 0, 1, 1, 2, 3, 4 and 5. So in order to, as you know, this is representing what? This is representing 6 meters. So you can write over here, this is meters. You have to write over here, this is meters. So what we had 6 meters over here, and we have to 6 meters. So every division is a 1 meter length, 1 meter. So this is 0.1 meter. So we had given in the question, we have to draw 4.56. we have to show it 4.56 meter, which is not possible, because this is 0.1 meter. We can show 4.54 plus 0.5 meters, but we can't show 0.56. so in order to draw, you have to take this from this corner, make a big box like this. Like you have to take any line and again make divisions. You can use your compass and make 10 divisions of this line. Any 10 divisions, you should take it as small as possible. 1, 2, as small as possible, but be careful, because compass doesn't work in small places. So this is why you have to be careful. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is 10. So at the 10th division, you have to make a box over here like this box, and you have to join this point over here with this box. You need to take 10 divisions, then you can join this. You can mark over here 10 division, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 divisions over here. So now you have to take these points exactly. You have to just mark this point 1, you have to mark this point 2, 3, 4, 5, 6, 7, 8 and 9. You have to just mark this point over here, and then to join, how to join these marks, take a small scale and join this 1 with 0, 1 with 0, join 1 with 0. Okay, join 1 with 0, join 2 with 1, join 2 with 1, making an offset of 1 division. Okay, join 3 with 2. Similarly, the 10th point will be joined with the 9th point. We can start with the back side also. Like this. Like this. So we have diagonally joined these points. Okay, Now you have to make these lines also. One, two, three, 7, 8, 9 and 10. So in order to understand how do we mark 4.56 over here, like you see, this is your 4 plus 0.5. This is 1, 2, 3, 4 and 5. So this is 0.5, this is 0.51, okay, this is 0.5254, this is 0.51, 2, 3, 4 and 5, 5, 6, 0.56, 0.57, 0.57, 0.58, 0.59 and then this is 0.5. This will become 6.56. We have traveled from 0.5 to 0.6, 0.5 to 0.6. So within that we had made this division. You can in order to understand like this, I am able to make you more understood. What we have drawn is, this is your one box, like this is our one box. We have diagonally joined this 0.5 and 0.56. This is 0.5 and 0.6 and we have diagonally joined this. So we have made 10 divisions. This is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So what I am talking about is that from 0.5 to 0.56. So now we have joined this. You see this. So this is 0.51. 0.51. Are you able to understand? This is 0.51, this is 0.52, this is 0.53. So up to it is going as 0.59. So this is 0.6. Are you able to understand? I had just make you understand how this diagonal works. So in order to mark 4.56, so just need to take 4 over here and 0.5 over here. 1, 2, 3, 4 and 5. Then 1, 2, 3, 4, 5 and 6. This is 4.56. This point you have to take it with a very light pencil, and take it the distance from here also and mark it as 4.56. This completes as your diagonal scale 4.56. So we have made a dimension which is up to 2 decimal point on this scale, which is not possible in the case of plane scale. Are you able to understand? This is called as diagonal scale. Diagonal scale. Okay? This is called as diagonal scale. This is question number 2, and if you turn it well, then it looks good on your paper. Okay, thank you. In this video I am going to explain you the third question. The third question of this assignment is also based on diagonal scale, and rest of this question is for vernier, and this is for isometric scale. So as earlier question, in this question it is given that the RF was in the second degree unit. So like 144 square centimeter is represented 9 square kilometer field. So how do we calculate? RF would be equal to under root the major unit, it is 144 square centimeter, and least unit and the major unit is at the bottom, 9 square kilometer. So when we take the under root, it will come into one dimension. If there will be a cube root of some dimension, then we have to take the cube root, means cube. Here something is in the volumetric form, this is aerial form. Then for volumetric form we have to take the cube root. So now the RF would become 144 centimeter square. Okay, now on the bottom side 9, we have to convert this into centimeter. 1000 meter, 1000 into this will 1000 will convert it into meter. Now for meter to centimeter we have 100. This is meters, this will come into meter, and then it will convert it into centimeter. Okay, so this is in the square form. So what would be it would become, this is 3, no, you should take it out, 12 by 3 into 10 to the power minus 5, because this square will be eliminated. Now the remaining part would be this is 4 into 10 raised to the power minus 5. This is the RF. So length of the scale, it is given that we have to make the scale up to 5 kilometers. You can see. So then LOS would be 4 into 10 raised to the power minus 5 into 5 kilometer, means 1000 meter and centimeter. So this would become 4 into 5 means 20 centimeters. So now you have to draw a 20 centimeter line, which is very long line, like this, 20 centimeter. Now you take any angle like this at any distance. This is 12 cm. This is the total distance is 20 centimeters. So you can write it over here. This is 20 centimeters. Now you take your compass and make because it is up to 5 kilometers, measure up to 5 kilometers. So this would be your, this you have to make 5 divisions over here. So first 1, 2, 3, 4 and 5 division, 5 equal division. Then you have to join this last point, 1, 2, 3, 4 and 5. Join these last points. And then tight your drafter like this as earlier. Now make a parallel line like this. These all lines are parallel. Now you make a box which you have to make dark. You have to make it dark. This box should be dark. Okay. Now as earlier I have told you it is a diagonal scale, so you have to you have to divide the first division also. Okay, and then you have to divide this first division into 10 parts as earlier I have shown you. You have to make any line at any distance, make 10 parts, 1 2 3 4 5 6 7 8 9 and 10. This is all 10 parts. Now you should join the last point of this arc and with this as earlier. Make your scale parallel to this line, and then you have to draw the parallel lines as in the previous questions. All these lines are very light. You have to keep your hand very lightweight while making these lines. After you had completed, just need to draw the vertical lines like this. In the same fashion, you have to make a box above this box, so you need to take the compass and make 10 divisions, 10 small divisions over here. 1 2 3 4 5 6 7 8 9 and 10. This is all 10 divisions, and you have to take this box. You have to make this box completed. Make a complete box and mark these dimensions over here. Mark these dimensions directly over here. As you can see, Now the point is you have to join these lines. First you have to join these horizontal lines. You can join this horizontal line first. This is 10 divisions. You can mark it here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 divisions. Now you should join like this 1 to 0, 1 to 0 like this. 1 to 0, 2 to 1, and for last point 10 to 9, 10 to 9th position, 9 to 8 position, 9 to 8 position, like this, one offset. One offset. One offset, and this diagonal is complete. This is a perfect diagonal. So now what we need to show, this is a 6 kilometer line. 6, it is representing 6 kilometer. So every division is 1 kilometer. I think it is 1 kilometer. So we have to show 3.56 kilometers. So this is 3, 1, as you know, this is 0, this is 1, 1, 2, 3, 4. So this is total is 1, 2, 3, 4, 5 kilometers. It is representing 5 kilometers. So this is 1 kilometer, 1 kilometer, and this is 0.1 kilometer. So in order to draw 3.56, this is 1, 2, 3, 3, and 0.5 is 1, 2, 3, 4 and 5, and 0.56, this is 1, 2, 3, 4, 5 and 6. This point will give you 3.56 kilometers. As in the previous question, this point you have to take it out, and from here you have to take it out 3. Every dimension with this, with one more resolution, you can draw it with the diagonal scale. 3.56 kilometers, kms, kilometers. You have to write over here kilometer also. This is kilometer. Is representing kilometers over here. So all this completed in a question number 3. This is a complete question number 3, as you can see clearly.